everyone. Good day, geometry. We are covering PO7. Mackie, the tic-tac away, please. Okay. And we've got some more angle definitions to discuss. In CO6, we talked about things like linear pairs and vertical angles. You see those two things pop up down here as well. But we're also going to talk about complementary and supplementary angles and then adjacent angles. Does anybody know, just by happenstance, what complementary angles are? Yes. Okay, so yes, complementary angles would be two angles that sum to 90 degrees. Okay, two angles that sum to 90 degrees. And they don't necessarily have to be touching. Okay, if you've got a right angle, so you know that at that angle's 90 degrees, and you divide it, right? Obviously, these two angles 1 and 2 here, are going to be complementary because of the angle addition postulate, right? They have to add to equal the whole angle, which is 90 degrees. But it's also possible to have two angles that are not adjacent. There's a hint for what that definition is. But if this was like 70 degrees and this was 20 degrees, they would also be considered complementary angles, okay? Because they do sum to equal 90, right? So they don't have to be touching, but it doesn't need only be two of them, and sum to 90 degrees. Any guesses as to what supplementary angles are? Remember those three numbers I gave you yesterday that were like, if you can add or subtract to these three, geometry is pretty much everything right there? Drake? Right, two angles that sum to 180. Okay. Now that sounds an awful lot like a linear pair, right? Because a linear pair is also two angles that add to be 180 degrees. But what's the difference between supplementary angles and a linear pair? Drake? What do you mean? Okay, so if you've got a straight angle that's been divided into two angles, right? Do those two angles make my calibration is way off here. Do those two angles make a linear pair? Yes. Are these two angles supplementary? Yes. But then what's the difference between supplementary angles and a linear pair? Drake? That's it. Supplementary angles do not have to touch, right? So if I had these angles separated, right? One like this and one down here like that, and this was, let's say 135, and this was 45, okay? They would be supplementary angles, but not a linear pair because they don't make a line. They still added 180, but because they're not touching, they're not connected, they don't make this line here, they would not be a linear pair. So minor difference there, but supplementary, two angles that add to be 180 degrees. And adjacent angles, what does the word adjacent mean, Joey?
Close together.
Next to, okay? So in this context, two angles that share a side. Okay, in order for angles to be adjacent, they have to be touching and they have to share a side. So in our original complementary angles example, because these two angles share that side, they would be adjacent. These two angles that don't touch, don't share a side, they are not adjacent angles. Linear pair angles are always also adjacent angles because they share a side, they touch. Those that don't, not adjacent angles. Okay? Good? Got the vocab down? Fantastic. So in the diagram below, angle 2 equals 90 degrees. Mark that in there. Angle 3 is 45 degrees. Give an example of complementary angles, supplementary angles, vertical angles, and a linear pair? Where do you want to start? You can pick any of those four to start with. Caleb?
Vertical angles, and the 2 and 5 would be vertical.
Okay, one option, angle 2 and angle 5. They share a vertex and are opposite each other. What's another option for vertical angles? Mackie?
I was showing the
Sure.
complementary.
Okay.
1 and 6.
1 and 6 are complementary. How do you know that those two add to be 90 degrees, though? Mackie?
Because if the line on the opposite side it's the same.
The line on the opposite side is the same?
Yeah.
What do you mean?
Like the angle 2.
Angle 2?
So that means the other side has to be the exact same.
Okay, so we've got a line going through here, right? And angles 6, 1, and 2 are the angles that make that line. They're not a linear pair because there are 3 angles and a pair is only 2. However, because angle 2 is 90, 1 and 6 together must also equal 90 to get that 180 those 3 angles make. So they're not a linear pair because there are 3 of them, but 1 and 6 are complementary because they know they have to add to be 90 to get the other 90 degrees to make that 180 that line gives us. Okay? Again, all about relationships, right? It's fantastic. Another one, Drake. Supplementary. What 2 angles are supplementary? 2 and 5. Okay. We're told that angle 2 is 90 degrees. Angle 5 would also have to be 90 degrees for them to be supplementary. And because we already labeled them vertical, meaning they are congruent, angle 2 and angle 5 do add up to be 180 degrees, making them supplementary. Good. Mackie, another option.
For complementary, 3 and 4.
3 and 4, same reason as 1 and 6, right? We've got another line coming through like this. We already know angle 2 is 90 degrees, which means that 3 and 4 together also have to be 90 degrees to get the total of 180 for the line. Do you kind of see what I mean here? How algebra and geometry are totally different. You know, we're using algebra. We've used algebra in our homework to solve for things. But as far as looking at these relationships, it's a different way to think, right? It's crazy. The people that are successful in algebra but struggle in geometry, and vice versa. Struggle in algebra, successful in geometry. Hopefully, you're successful in both, but it is a different part of the brain used. Linear pair. We don't have any linear pair yet. What do you got for that? Yeah. Angle 3 and 1. I'll mark angle 3 and mark angle 1. Do those 2 angles make a line? No. We got that angle 2 that's part of that line also, which is not part of 1 or 3. So we don't have a linear pair there. Linear pair, 2 angles that make a line? Anybody? Drake? No? You mean no, you don't have an answer, or no, there aren't any? There are, no. No linear pairs here because nothing fits that definition of 2 angles that make a line. Okay? If we wanted to combine, for example, angles 2 and 3 and call this angle 7 now, then we could say that 1 and 7 make a linear pair, but as the diagram is drawn, no linear pairs. Questions? All right. We got about 5 minutes left. Let's see what we can do with that here. It says for 1 and 2 below, find the measure of angle GEF. For the third diagram, find the value of X and Y. And remember, geometry is all about relationships. Everything about the diagram must work. This is very similar to CO6, only we're adding other vocabulary to it, complementary, supplementary, okay, adjacent. What equation are you going to set up here for the first one? You want to find the measure of GEF, which is this angle right here. What equation are you going to set up? Gino?
18x minus 9 plus 4x plus 13 equals 180.
Good. 18x minus 9 plus 4x plus 13 equals 180. Those two angles are a linear pair. Those two angles are supplementary. Their sum has to be 180, and now we do go back to the algebra to actually solve this. Okay? Let's go to the third one. How are you going to go about solving that? Think about all the relationships that we have here. There's plenty of options. We've got vertical angles to work with. We've got linear pairs to work with. What can you set up?
Six x plus 4x
6x plus 4x
equals 90.
equals 90. Where do you get 6? Oh, sorry. I'm talking about the third one. That one's pretty, but the third one looks complicated. And it's the last one. I love, you always like to ask about the last one. What can you set up here? Yeah.
So for y, 2y plus 3y plus 30 equals 180 since they made the slanted line.
Sure. Same kind of deal here, right? And then to solve for x, you can set up a similar equation there, okay? Since you get 180 between 4x minus 100 and x plus 5. Or once you solve for y, and you can calculate what 2y equals, you could set that equal to x plus 5 since they're vertical angles. You can solve for x that way too, if you find that a little bit easier. It's a one-step equation versus several steps. Okay, so you can either kind of go with that 180 for both your y and your x's, or once you solve for y here, just plug that in for the y variable, get the actual degree measure of that angle, and set that equal to x plus 5 since they're vertical angles. The brain busters at the bottom. The first one says one angle is 3/2 times the measure of its complement. What are the measures of the angles? One angle is 3/2 times the measure of its complement. Mackie?
What is complement mean?
What does complement mean? If an angle has a complement, what is that saying? It's really kind to other people, Nathan? It means that it has to add to 90 degrees. Okay? So if you have an angle that's 30 degrees, its complement would be 60. Right? So let's kind of set this up a little bit. Let's call an angle what we're trying to find. We'll call that x. We'll assign it the variable x. And that angle is, what does the word is mean in mathematics? Equals. So an angle is equal to 3/2 times the measure of its complement. Here's the other side of our equation. 3/2 times the measure of its complement. Well, the word times means we're multiplying, right? So we're multiplying 3/2 times something. How do we verbalize the measure of its complement? In the example I gave Mackie or Gino, whoever it was, if I said if we have an angle that is 60, its complement would be 30. How could we calculate that?
You put in your calculator 3/2 and then parentheses 90.
90. That's not all of it. If you knew an angle was, I gotta let you go. If you knew an angle was 60, how would you calculate its complement to be 30? What calculation could you do to knowing an angle is 60 to knowing its complement is 30? 90 minus 60, right? So if we know our angle is x, its complement would be calculated by taking 90 minus the measure of that angle, and there's the equation that you're solving. So you're close. Okay. an angle is 3/2 times the measure of its complement is 90 minus x. I got to let you go. Your homework is to finish this page. Have fun with the last one there. Nothing from the book, but that's how you math. Don't forget to like and subscribe. Have a great